Hmm? Salut tout le monde. Aujourd'hui, je vais vous présenter une de mes collègues. Je travaille avec elle depuis une année, Raqeebir. Raqeebir, elle est au Bangladesh. Elle est professeure là-bas à l'université Ahsanullah de technologie d'informatique. Elle a fait ses études ici au Canada, à la Colombie-Britannique, pour son baccalauréat. Puis elle a fait sa maîtrise ici à l'université de Concordia. Elle prévoit faire son doctorat avec Hafid et moi prochainement, très prochainement. Elle travaille beaucoup sur les réseaux sans fil. Aussi, dernièrement, elle fait beaucoup d'apprentissage machine. On prévoit de travailler sur justement la conception et le développement de robots intelligents dans le contexte de la RPA, Robotic Process Automation. Donc aujourd'hui, elle va nous parler de la relation entre, d'après ce que j'ai vu, personnalité et émotion et comment elle modélise ça. Donc voilà, you can start, Raqeebir, and you should expect questions during your presentation, okay? You are not,
Yes, sure.
okay, so you can start.
Okay, thank you. So hopefully I'm visible to everyone. Hello, I'm Raqeebir. I'm currently working as an assistant professor at the Department of Computer Science and Engineering, Assam University of Science and Technology, Dhaka, Bangladesh. So today my presentation topics is uh, the personality and emotion, a comprehensive analysis using contextual text embedding SBER. Actually, it is an application-oriented research to apply NLP, natural language processing model, to find or to investigate the personality and emotion based on the context of social media post using natural language processing model as like ACE BERT or sentence BERT. So before starting my presentation, I should tell you actually what is personality and emotion. So personality actually, the way humans actually behave, think, and it is actually the inner behavior of a human. On the other hand, emotion actually the intermediate or immediate reaction of sentiment, expression, or feelings. In both are actually interrelated. Sorry, there could be a chance of some low signal level. Hopefully I'm audible. If I'm not audible, please inform me. So what was saying that and there is interconnection between these two with the human psychology and mental health. So in this research, actually, we try to connect the human psychology and mental health based on the social media post of humans' personality and also the emotion. So our works actually investigate the the complex relationship between human personality and emotion based on the social media post. Because peoples are now more prone to use the social media, and where they express their feelings, their thoughts, everything. And based on that, we can actually predict the not on predict the personality and also emotion. But here we actually link between these two factor of any human's life or human's behavior. So the motivation of our work is the social media's roles in communication and self-expression, investigate the complex relationship between human personality and emotion, and automate the overall process. So our problem that we want to solve is exploring the link between the personality and emotion based on social media, text, not other medium, utilizing advanced model for contextual understanding, like NLP actually have developed a lot. So we try to apply the advanced model and enhance the predictive capability. So our work is actually divided into two parts. In part one, we actually predict the human personality using different machine learning models. And the second part is comprehensive analysis between human's personality and emotions. So for both the part, the basic steps are similar, but there is of course, there's a difference in the other methodology also. So any machine learning process, first we need a data, because without data, we cannot train or predict, we cannot train our model, right? So in this research, we use 3 data set to explore the relationship between personality and emotion. One is Myers-Briggs Personality Type Dataset, MBTI, which is obtained from the Kaggle. The ECMO Emotion Dataset, and the third one is NRC Emotion Lexicon. So what is Myers-Briggs Type Indicator? It is actually a personality type indicator model. There is a several model. So, but the two popular model is MBTI, another is Big Five. But we choose MBTI because it has more significance in human personality, and also we can relate more with the emotion than the Big Five. And also the Big Five and the emotion linking with Big Five emotions and Big Five personality and emotions, the research is already has been done. So we that's why actually we choose MBTI. So MBTI identify individuals into 6 unique personality types based on 4 dimensions. The dimensions are feeling versus thinking, intuition versus sensing, perception versus judgment, introversion versus extroversion. So the 16 types is actually combination of each from this 4 dimension. Like one type, MBTI personality type is ISPF, which is introvert. The person is introvert with sensing, then has some judgment capability, and also do the thing based on feelings or thinking something. So there's a 16 unique combination of this. So MBTI dataset, it is a public dataset. We got it from Kaggle. It contains 8675 rows, and each individual has 50 posts written by each user. So figure 1 actually shows the data set, the snapshot of our MBTI dataset. Then emotions. So for emotion model, also there is several emotion model, but here we choose Ekman model because Ekman model composite six basic emotion, which is universally recognized. Sorry, the emotions are happiness, sadness, anger, fear, disgust, and surprise. And the model is developed by psychologist Paul Ekman in 1992. So the emotion dataset, our second dataset is emotion dataset, or we can say Ekman emotion dataset. So there is actually no comprehensive dataset for Ekman 6 emotion dataset. So here also we need to customize our dataset. So the text actually contains expressing different human emotion and their emotion levels. We customized our dataset by combining two datasets. One is EDERT, which has 5 Ekman emotion except disgust. For disgust emotion, we have taken the text from BKSBEC. So then we add this with the EDERT and customize our new Ekman emotion dataset. So the right hand side, you can see the EDERT dataset. And all these datasets actually are publicly available. Okay, our third dataset is NRC Emotion Lexicon, associated with the list of words for different emotion, and was created by National Research Council of Canada. It is here also we customize our dataset by combining the similar emotion, because we have found that especially the emotion to predict the emotion in text is very challenging, because the emotion can be identified not more, more than text by facial expression, your voice tone, etc. So for this purpose and to get more accurate prediction of emotion based on the 16 personality type, we customized our NRC, the NRC emotion lexicon in 3 separate dataset where we combine the similar emotion in one as a one emotion, like joy and surprise combined as positive affection, which include the positive feelings, anger and disgust as a negative aversion, which is composite of negative reaction, and then sadness and fear combined as negative distress, which includes distressing emotion. The figure 3 actually show the lexicon emotion dataset. So here actually we customize 2 dataset. One is Ekman dataset and another one is NRC emotion lexicon. So now this is the methodology of our proposed approach. So any natural language processing model or the machine learning models involve these 5 steps. The first is data preparation, which I've discussed the previous slide also, that we customize our data set for better prediction. Then data preparation also include data pre-processing. Then we have to do the feature extraction, then model selection and training, performance analysis, and then model deploy. Methodology, the pre-processing part, this is very important. So we need to clean the data, and especially for MBTI dataset, it's a social media post. So it includes URL, video, image, emojis. So we need to remove all these for better understanding purpose. So then we need to tokenize our data. Then we have to remove the stop words like and or, because this has no significance meaning or meaning in our text processing. And then we lowercase all the tokens. So pre-processed data, we have there is a several part. So first is we need to handle the imbalanced data, then we have the tokenization, and then lemmatization. So handling the imbalanced data is very important because if the data is imbalanced, it leads to biased or inaccurate model and can be handled using oversampling and undersampling. Tokenization involves identifying and separating the text into relevant chunk, convert unstructured text into a structured format. Lemmatization, though we didn't use it here, changes word into lemma form, reduce inflected words to standard form to improve the text data analysis. So this is the data visualization of our 16 MBTI type, and you can see the data is fully in balance. Like the predictive, that MBTI type INFP has a huge number of data, and EST has a very small. So if we train our prediction model with this data, then there could be a biasness of the majority class. So to remove the biasness of the majority class, we need to balance our data. There is a several way to balance data. So there's a sampling, oversampling and undersampling. But in this case, we use random oversampling where the minority classes are duplicated randomly to remove the biasness of the majority class. So you can see a figure of before random sampling and after the random oversampling. There is a several other random sampling method also, but we choose this one. And the tokenization, as I told you, that tokenization is dividing the word from the sentence. Then feature extraction. This is a very important part of any machine learning process and also the NLP process. So the machine learning or any classification model cannot process the raw text. So we need to convert it to numerical value. And there is several ways to do this, like a TF, IDF, word to vector. Those are vectorize the text into numeric value. But those actually model cannot capture the contextual meaning of a sentence. Because in our case, we need context, because contextual meaning of the sentence, I mean the semantic meanings, to understand the personality and the emotion of which is hidden in that sentence. So that's why we have used this sentence embedding process, which is very popular ACE board, a sentence board, which outperform the board and takes less time. ACE board, actually, this is a transfer learning model and based on transformer and encoding decoding approach. So ACE-BERT model that we used, pretend model that we use is it is written LLMPNet base version 2. This generate contextualized sentence embedding and train on over 1 billion training data. Tokenization embedding construction, byte pair encoding algorithm tokenize the sentence into a series of subwords and is represented by an initial embedding vector. Integration of subword embedding, contextualized embedding for all subwords are integrated into 768 dimensions vector. So the ACE board actually find the similarity between similar sentences and minimize the similarity of the dissimilar sentences. So it is a very latest model of BERT. So this is actually the figure after the SBERT embedding. So you can see that there is a 738 vector in the second column, sorry, third column for the each post. So this is our overall block diagram of our first part for MBTI personality prediction. Here we have a social media post on the MBTI dataset. And we pre-process our data by implementing random oversampling, data cleaning, and stopword removal. Then we use embedded our sentence using SBERT, or you can say more like a feature extraction. Then we implement four a basic machine learning algorithm: logistic regression, support vector machine, random forest, and k-nearest neighbor for MBTI prediction. So these are the model. We have used logistic regression. The regression model is a supervised learning and used for predictive analytic approach and based on the concept of probability. It is implemented when the dependent variable or the class but target is categorical. Support vector machine, which is more known as SVM, which is also supervised learning and solves for classification and regression issue. Its goal is there is a hyper parameter or decision boundary, which actually divergence between the two or more groups. K-nearest neighbors, KNN. This is another popular machine learning technique in classification and regression task. It is also relies on the idea that the similar point data will be close together. And the fourth one is an ensemble model, which is random forest. There is a multiple decision tree used to create a prediction. It can manage a large amount of data and minimize the overfitting and provide reliable prediction. So this is the performance analysis of our 16 MBTI classes. And you can see that the performance is very low. With KNN, we got the KNN and logistic we got very close, and it's very, the accuracy is very less than, very small and less than 50%. So to solve this problem, what we did is we divided our 16 class to binary classes. So our first binary classes are extroversion and introversion. And then we apply our full model to the binary classes. And you can see that the performance actually increased significantly. And SVM actually show the better result among, sorry, not SVM, random forest actually outperforms the other three. So our second binary classes are sensing and intuition. Here also random forest outperform better. Then our third binary classes are thinking versus feeling. Here also random forest perform better. And the fourth one is judging versus perceiving. Here also the random forest do the good job. This is the confusion matrix of random forest. So this is the performance analysis. There is a binary classification of individual the 4 dimension of the MBTI data. There's this previous work also. So they use BERT or statistical feature, but we use SBERT and got better result than them. So as you see that our MBTI data is actually 16 type. So what we did that we combined our binary classes into MBTI personality trait. What we did is that we take this is a table that we take one row or one post, and which is actual MBTI type is INFJ. And our prediction model choose INFJ with the maximum prediction probability is 90% for intuition and introversion, 70% for intuition, 80% for failings, and 75% for judgment. So the overall prediction probability is good. But for the dataset row number 402, there is false prediction, like the actual MBTI type is INTJ, but instead of T, the prediction model predict F, and the probability is 61%. So out of 4, only 1 is predicted false. Otherwise, it predict the 16 type more or less accurately. So now I will, this is actually published in 10th 2023 conference. It is the IEEE conference held in Melbourne, Canberra, Australia. So this is the second part of our work, where we actually investigate the relationship between the emotion and the personality. Here also, we need to prepare our data set, especially the lexicon data set. Actually, not lexicon, actually also the Ekman, but I will explain it with Ekman data set. So our, as I told you before, during the data acquisition also, that we divided the similar emotion into one group. So we have 3 groups now. One is negative distress, positive affection, and negative aversion. And these are actually imbalanced data. So we use random oversampling to balance the data. Okay. Then our investigation of or finding of the relation or interconnection between the emotion and personality has involved 2 phases. The phase 1 is we find the similarity between the MBTI dataset and the NRC lexicon model, NRC lexicon dataset. So for this, there is several text similarity method, like Manhattan distance, Euclidean distance, but we choose cosine similarity. It measures the similarity between 2 vectors respective to their size, measures the angle between 2 vectors in a higher dimensional space. The smaller the value of the angle, the higher the value of cosine similarity. So the equation for to calculate the similarity is showing in the right-hand side. So here DOC1 is actually our MBTI dataset, and DOC2 is our NRC dataset for 3 separate group of emotion. One is positive affection, negative distress, and negative aversion. So we use this equation to calculate the cosine similarity. And if the cosine similarity score is below 0.1, then we discard those posts for further prediction, and we indicate the negligible connection between the post and a specified emotion. So of the phase 2 of our second methodology is cross data model prediction. Here, the model mainly focus on using a based predictive model trained to predict emotion on the MBTI dataset without retraining or adjusting the model's parameter. So here we've first embedded our Ekman emotion dataset using SBIRD. And then we train our data using machine learning model like KNN, SVM, logistic regression, random forest, and decision tree. And then with this model, the model which performs better, we trained our MBTI dataset without, or we can, most I can say that we test our MBTI or predict our MBTI dataset for emotion prediction without retraining or adjusting the model parameters. So that was actually two phases for doing the same purpose. One is find the cosine similarity to predict the emotions from the MBTI post. And also the another one is cross data model prediction, which is also predict the emotion for the MBTI datasets. So now the domain is actually the same. Both cases, the prediction domain is MBTI dataset. So because these models are actually unsupervised, there is no because the unsupervised learning, we cannot say that this is actually for this post, this personality, this emotion is true. It's something like that. So for this, to increase the authenticity and reliability of our overall process, we implementing the weighting process. The primary goal of weighting process is verifying the authenticity and reliability based on some specific criteria. The criteria is if both model prediction and cosine similarity prediction are the same, only those predictions are considered as a final emotion prediction for the specific post. Otherwise, it will discard. This is the overall proposed methodology of our emotion prediction. You can see that we have uses 3 different datasets to implement our methodology. So in the green part, it's here we the dataset is MBTI dataset, and we have 16 MBTI types. These are raw classes and imbalanced data. We pre-process our data by data cleaning and stop-work removal. Then we implement sentence embedding for find the contextual embedding of our MBTI dataset. And now the gray part of our is find the cosine similarity between the NRC emotion lexicon and the MBTI dataset. Here, the NRC emotion lexicon has 6 emotions: joy, surprise, angry, disgust, sad, and fear. Then we grouped the similar one in one group, like joy and surprise is a positive affection, angry and disgust, negative aversion, sad and fear, negative distress. This one also, now we have 3 groups of data. So here we implement sentence embedding on 3, and then we find the cosine similarity between the MBTI dataset and NRC, like emotion lexicon. So if the highest score, similarity score greater than the threshold 1, we have two threshold value. Threshold 1 is 0.1. Then we consider it consider that emotion as the final one. And in some cases, we found that the similarity score between 2 emotions is very close, and we cannot actually differentiate to that this person, the person's post belongs to which group. So for that reason, we use another threshold value. That is, if the highest score and second highest scores, the difference is less than 0.03, then we actually consider we cannot distinguish between the group of the emotion. So we discard that post for further prediction. So now this is actually our phase 1 with the cause and similarity. Then our second phase is predictive model. Here, our Ekman emotion dataset that we customized, as I described before. Here we also have a 6 emotion, but we grouped into the 2 with the similar emotions: positive affection, negative aversion, and negative distress. Then our raw class are imbalanced data. So we use implement random oversampling, data cleaning and stop word removal. Then we applied sentence bird to find the contextual meaning of our sentence. Then for training, we used this 5 model. And we found that among the 5, the SVM actually giving more accuracy for prediction. So what we did is we choose SVM as a predictive model, and then we test our MBTI dataset without any changing and with the pre-training with the SVM. Then our SVM give our predict the emotion for the MBTI dataset. Now we have 2 prediction. One is using the similarity prediction and one is model prediction. So to increase the authenticity and reliability, now we use the vetting process. The vetting process, if the 2 model prediction for each particular post is same, then okay, now this is actually the final prediction. If there is a mismatch, then we can discard that post. So this is actually our proposed methodology for human emotion and personality relation. So this is the performance analysis on emotion prediction. The emotion assignment for cause and similarity. If I can see the social media post in row 1, you can see that the negative aversion has highest similarity score. So the emotion assignment is negative. The second post has a negative distress assignment because it has the highest similarity score. And the third one is positive affection. So here we assign the emotions of the MBTI dataset using the cause and similarity. So the cross and the second phase, the cross data model performance. Here you can see the SVM actually perform better than in all the performance metrics, precision, recall, and influence score. So we choose SVM as a predictive model and predict the emotion of MBTI dataset using SVM. So this is the vetting process. So like a first post, social media post, the cause and similarity prediction also negative aversion. The model also prediction also negative aversion. So the vetting is selected. The last one, you can see that cause and similarity prediction is negative distress, but model prediction is negative aversion. So this is not selected. So this is the performance analysis of vetting process. So we can see that of all the 16 MBTI types, both the agreement percentage of both the model is actually almost more than 85%. So actually our methodology works very significantly to find the relationship between the emotion and the personality. So here is the association between MBTI type and the emotion. So this is the bar chart. So you can see that the blue one is positive affection percentage, the negative, the orange one is negative distress, and the yellow one is negative aversion. So you can see that most of the people actually like to post positive post in the social media, and they are very not too inclined to post the negative things in the social media. This is the correlation between MBTI traits and positive affection. So how this that each individual MBTI type has post which emotions related social media post more. Like you can see that this is the positive, the y-axis represent the positive affection percentage, and the axis is the MBTI traits. So the individual who is extrovert with sensing and feeling capability is more tends to post positive affection types post. Then if I can see the relation between MBTI type and negative aversion percent, you can see the people who is more like a thinking capability with who is also extrovert and intuition of something and very perception about the decision are more likely to share negative aversion type post in the social media. And the third one is negative distress percentage. So people's with introvert and with the intuition, thinking, and judging capability, they are more like express negative distress emotion in social media platform. So this is actually overall relation of the MBTI personality and the ECMA emotions. So this is the end of my presentation. So in this research, actually, we try to automate the prediction of personality trait and emotion using NLP techniques, utilize sentence board for contextual embedding of text, aim for a more comprehensive understanding of online behavior, provide insight into how different personality traits express and feel emotion. So that's all actually of my presentation. So thank you. And if you have any questions, you can ask me.
Thank you, Raqeebir, for your presentation, and thank you for having this talk late. I think it's around 1 a.m. at Dhaka. Yeah. So, any question? Des questions, Hafid? On s'attend à moins de questions. Okay, Hafid has one question.
Yeah,
It's
yeah,
around,
sure.
yeah, it's around 1
My
a.m.
internet connection.
Okay. Are you hearing? Yeah.
Yeah, I'm hearing.
Okay,
Yeah.
so
Am I
Hafid,
audible?
what?
Can you hear me or?
Yeah, I'm hearing you.
Okay. Yeah,
Hafid has one
thank
question.
yeah, sure.
Yeah, thank you very much for the excellent presentation. I missed
Thank
part
you.
of it because I couldn't attend from the beginning, and because also I don't know anything about what you talked about. But I was curious. There was there was one kind of personality trait or something where the prediction was not very good, the 61%. Can you go over that again, what that is, and why do you think your prediction with the algorithm was not very good for that particular combination?
Okay, yeah. Just a second.
Yeah, that one. Sorry.
This one, right?
Yeah. Can you go over again what that represents? And if you can elaborate on why do you think that didn't perform as well as the others?
No, not because actually these MBTI types like INTJ, these are the prediction model, the percentage that they predict is based on the text data. So sometimes the prediction model, if I can show you that our model which performed better was random forest, and it is not for the like it is classify what misclassify the T and F. So if you can see for T and TF, just a second. Thinking and feelings, the random forest, actually the accuracy is not 100%, right? So there could be a misclassification. Also, if you can see the confusion matrix also, there is some misclassification also here. So there is a chance that there could be a misclassification.
Perhaps if you
it's not 100% accurate, right?
Yeah. If you can go back to the slide that shows the results with the red line. Yeah, okay.
Yeah, this one.
Perhaps if you just explain what the acronyms mean, INTJ and F.
Oh, IN is introvert, N is intuition, F is feeling, and J is judgment. This is actually the MBTI types of personality.
Okay, so it's so what does?
So if I can actually, if I go a little bit more previous, like show you. Actually, this is actually MBTI type indicator of the personality. It identifies 16 individual personality from the 4 different dimension. So one dimension is feeling versus thinking. One dimension is intuition versus sensing, with I and S, and N and S. And then one dimension is introversion versus extroversion, and one is perception and judgment. So from each of the dimension, here, by picking up the one, each of the personality, they combined the 16 unique personality. Like one combination is introversion, intuition, feeling, and perception. One is like INFP. Then one could be extroversion, sensing, thinking, judgment. Then it could be ESTJ. So here they combine into 16 personality types.
The reason I'm very interested in that one red line, and I'm maybe telling this for the benefits of the students. When I was doing my PhD, which was a long time ago, my research advisor told me, and Yasmin will like this, if your methodology is right, the negative results are much more interesting than the positive ones.
Yes.
So that's why I'm interested in this particular case. What does it tell us about this combination of personality traits that makes it difficult to predict? So that's what I'm getting at. And if you have some feelings about that, or you have some opinion about it. Yeah.
Opinion is like I told you that they actually misclassify thinking versus feelings, right? It should be thinking, but they predict as if I'm not making a mistake.
Okay. Thank you very much.
Yeah, no, I just like it should be a thinking, but it predict feelings, right? So that is that if I can go to the confusion matrix also, like thinking versus feeling, you see that there is some misclassification also. Like for feeling, they are actually also, there should be feeling, but they are predicting thinking. So there's this one is 161 post for this type also. So that's why actually, because actually this is more like, from there also actually we can predict that that our model uh, uh, need probably more analysis to predict more accurately all the types, because the text, actually the social media text are not very understandable. It's very difficult to find the conceptual or contextualization meanings. But we'll try, actually we'll try to improve that part also. So actually it's very difficult to distinguish between thinking and feeling some cases. Yes. Person. So any more
questions? Yeah, 2 questions.
Yeah.
Thank you very much for the presentation. It was very interesting.
Thank you.
2 quick questions about the INFJ. One is about slide 17, where you showed the distribution of your data set.
Yeah, sure. 17.
I think there was a distribution of the different personality traits from your data set.
Oh, yeah. Here? Yes.
Yeah. So I was a bit confused about this one because INFJ, the second one, it amounts for about 2% of the world population. And here it's the second highest. So maybe you quickly elaborate on how you can explain like the discrepancy between your visualization here from the data set.
Actually, the visualization is based on the data set, right? The data is like something is like totally imbalanced. That they have a post with a target value of more like INFP. And they have less posts of prediction, target value of ESTJ.
Have you tried your approach with,
yeah, actually, yeah, we draw this, we plot this bar diagram. So based on the row that we have, so the data is almost 8,600. So based on this, actually, we do this. That's why actually, because of this imbalanced data, we actually try to balance our data set using random oversampling. You can see now the data are not that much, pretty much balanced. And also, if you can see that when with the performance analysis also, when we try to predict the with this imbalance data set, our prediction accuracy also very low.
Okay, thank you.
So that's why actually we solved this problem. We actually went for the binary classes, and then later on we combined those binary classes again to find the MBTI type.
Have you found another data set that's closer to representing the, so to speak, the ground truth?
No, actually, this is actually the only data set for MBTI which is publicly available.
Interesting.
So
okay, then I think the follow-up question is already answered, but it would have been usually the MBTI matrix is also amended by a 5th factor, which is turbulence and assertiveness of the subject. Do you have any insights on how this comes to play with your prediction, or did you consider it for your predictions, or was this just
for that which one? This one?
Well, you have the 4 factors for
oh, the confusion matrix. Actually, yeah, this is this can be actually minimize or the using we actually didn't try any other way, but actually now there is a more language model, right? And GPT is there, so I
No,
think if we can
so it
yeah,
was mostly
can...
that usually there's a fifth factor, right? It's not just the sensing and intuition and the introvert, extrovert, and so on. There's a fifth factor, which is like how assertive your subject is, like how strong they are confident in their own opinions. And did this
yeah, that could be another one also, that if they if yeah, in theoretically, yeah, they could be probably they are not confident. They are not confident because sometimes there is a language things, right? So each word can be meaning, you can make a meaning of in a different way. So that could be another thing also.
But it was not part of your data set, so to speak. So
no, it's not a part
okay.
of our data set. No. Yeah.
Thanks,
but we try to capture the contextual meaning of the sentences. So probably, yeah.
Okay, thanks again.
Okay, thank you.
Question? No? Okay, merci. So thank you, Raqeebir. Thank you for your presentation. And, we'll talk about later. Merci tout le monde. Je peux-